All right, let's get into it. Today, we're unpacking one of the greatest scientific stories ever told. Seriously, it's about how our entire understanding of reality got completely turned on its head. We're talking about a shift from a universe that was seen as this perfect, predictable clock to one that's dynamic, flexible, a place where even space and time can bend and warp. It's wild. So, you gotta ask, why did the universe need a whole new operating system? I mean, for over 200 years, it felt like we had it all figured out, thanks to Isaac Newton. His physics just worked perfectly. His laws were elegant, powerful, they explained so much. But then, they didn't. As the 19th century wrapped up, this one really stubborn mystery about light popped up, and it basically forced a complete rewrite of all the rules. Okay, so before we can really get into the revolution, we have to understand what it was replacing. To appreciate just how massive this change was, let's first take a look at that seemingly perfect world, the universe according to Isaac Newton. In Newton's world, things felt, well, they felt simple, really intuitive. You had space, which was just this fixed, unchanging stage where everything happened. And then you had time. Time was like this universal master clock, just ticking away at the exact same rate for everyone, everywhere. For you, for me, for an alien on the other side of the cosmos, it was all the same. Absolute. And his laws of motion, oh, they were just brilliant. You've got inertia, an object in motion stays in motion. Check. You've got F equals ma, the very heart of how things move. And then there's universal gravity, this invisible force that pulls everything together. I mean, for 200 years, these laws explained everything from a falling apple to the orbits of planets with just incredible accuracy. It really did feel like we lived in a predictable, reliable, clockwork universe. But you knew there was a but coming, right? Towards the end of the 19th century, a tiny crack started to show in this perfect clockwork machine. And it all came down to one thing: the really, really strange behavior of light. Okay, so scientists back then knew that light acted like a wave, and that made sense. But, waves need something to travel through. Sound waves have air, ocean waves have water. So what did light have? Well, they came up with this idea of an invisible, undetectable substance that filled all of space. They called it the luminiferous ether. It was like this cosmic ocean that light waves were supposed to ripple through. And this is where everything started to fall apart. Think about it this way. If you're on a train that's moving at 50 miles per hour and you throw a ball forward at 10 miles per hour, somebody on the ground sees that ball moving at 60. The speeds just add up. Simple, right? But light just refused to play by those rules. It didn't matter how fast you were moving towards a light beam or away from it. When you measured its speed, you always got the exact same number. It was completely baffling. And that number is almost 300,000 kilometers per second. This isn't just a guideline. It's like a universal speed limit. It's an absolute constant. And this was confirmed by this really famous experiment by Michelson and Morley. They figured, okay, as the Earth orbits the sun, it must be moving through this ether. So we should be able to measure a difference in the speed of light, kind of like swimming with or against a current. But when they did the experiment, nothing. No change at all. The stunning conclusion was that this cosmic ocean, this ether, probably didn't even exist. So this leaves physics with a huge, impossible question. How can the speed of light be the same for everyone? I mean, seriously, think about that. How can a beam of light leave you at the same speed, whether you're standing still or chasing after it in a rocket ship? It just doesn't make sense. The rules of Newton and the rules of light were in direct conflict. They could not both be right. So how do you solve a problem that seems literally impossible? Well, this is where a young, pretty much unknown patent clerk enters the picture. His name was Albert Einstein, and he didn't solve this with some fancy new experiment. No, he solved it with an idea, a breathtakingly simple and totally radical idea. See, instead of trying to make light fit the old rules, Einstein did something genius. He just accepted it. He said, okay, what if the speed of light is the one thing in the universe that's absolute? What if that's the rule that can't be broken? And if that's true, and the laws of physics are the same for everyone, then something else has to give. Something has to be flexible. And that something was space and time themselves. Right. In order to keep the speed of light constant for you, me, and everyone else, Einstein figured out that space and time couldn't be separate things. They weren't a fixed stage in a master clock anymore. Instead, they were woven together into a single four-dimensional fabric. He called it space-time.
And here's the kicker. The faster you move through space, the slower you move through time. They're connected. And this new reality gives us a new way to think about our journey through the universe. Every object, you, me, a planet, a photon of light, is charting its own unique path through this 4D space-time. It's not just your path through space, it's your path through time, too. It's your entire history of events, all mapped out. It's called your world line. But believe it or not, Einstein wasn't done. Not even close. After completely turning our ideas of space and time upside down with his theory of special relativity, he set his sights on an even bigger target, the biggest force of them all, gravity. You see, there was this other really deep puzzle in physics. Why is it that an object's mass does two completely different things? On one hand, it's a measure of inertia, how hard it is to get something moving. On the other, it's a measure of how much gravity pulls on it. Newton's laws just accepted this as a fact. But to Einstein, this wasn't just some weird coincidence. He thought it was a giant clue pointing to something much deeper. And this led to what he called his happiest thought. It's a brilliant thought experiment. Imagine you're in an elevator with no windows, way out in deep space. If that elevator starts accelerating upwards, you'll feel yourself being pressed to the floor, right? Now, how is that feeling any different from just standing still in an elevator on Earth, feeling the pull of gravity? The answer is, it isn't. You can't do any experiment inside that box to tell the difference. And for Einstein, if you can't tell the difference, there is no difference. They're equivalent. And this idea, the principle of equivalence, led him to his most incredible conclusion yet. Gravity isn't a force pulling things across space. No. Gravity is the curvature of space-time itself. Mass and energy literally tells space-time how to bend. And in turn, that curved space-time tells objects how to move. So a planet isn't being pulled by the sun. It's just following the straightest possible path through the warped, curved space around the sun. So this new theory, general relativity, did more than just explain gravity. It gave us a whole new way of seeing the entire cosmos. And look, this wasn't just some neat philosophical idea. It made real, testable predictions. For example, it perfectly explained this tiny little wobble in Mercury's orbit that Newton's math could never quite account for. But even crazier, it predicted that something as massive as the sun would bend space-time so much that it would actually change the path of starlight passing by. And in 1919, during a solar eclipse, astronomers looked and they saw it. The starlight was bent, exactly as he predicted. Einstein was right. So, why does any of this matter to you and me? Well, Einstein's big ideas aren't just for astronomers. They're literally built into the technology we use every single day. Take the GPS in your phone. It only works because it accounts for relativity. See, time actually ticks a tiny bit faster for the satellites up in orbit than it does for us down here on Earth. Without correcting for that difference, your GPS would be off by miles in just one day. So yeah, Einstein gave us a new operating system for the cosmos, and it's being proven right every single time you ask your phone for directions. And all of this leaves us with one last kind of mind-bending thought. If our deepest, most common sense intuitions about space and time turned out to be wrong, what else might we be wrong about? Einstein's journey proves that even our most fundamental assumptions about reality are up for grabs. And it shows us that the universe isn't just stranger than we imagine. It might just be stranger than we can imagine.